Okay, so another technique that we have, which it's kind of strange to refer to it as own proof technique, but for our purposes, we'll call it a proof technique, um, is if we want to prove P implies Q, then we can instead prove not Q implies not P. And that comes down to how this guy is defined. P implies Q is technically Q or not P. Sorry, or not P. And that is the equivalent to this guy. So don't get too hung up on that because we're not really talking too much about the symbolic logic, but be aware that all of these three statements are equivalent. And that this is very different from the inverse that this is. So P implies Q is the same thing as not Q implies not P, but they're not the same thing as the inverse of Q implies P, or the converse of not P implies not Q. These two guys are the same. Cool. So I'm just going to give you one example. I don't think that it'll come up too often in this course, but it is often useful. And this is the name for this right here is material implication. That's the name for this type of implication that makes these two things equivalent. Material implication. So if I want to prove that if x squared is even, then x is even, then instead I can prove by contrapositive this statement. To if x is not even, then x squared is not even. So for this whole thing, x is an integer. The same equivalent to saying x is not even or x squared is not even is saying i.e. x is odd. If x is odd, then x squared is odd. And let's show this. If x is odd, then x is equal to 2k plus 1. Therefore, 2k plus, or therefore, x squared is equal to 2k plus 1 squared. And that is, if we just FOIL this out, that's 4k squared plus 4k plus 1. That's equal to 2 times 2k squared plus 2k, all plus 1. This is an integer. Therefore, this guy, therefore, x squared. So this looks like 2 times an integer plus 1, therefore x squared is odd. Therefore, our original statement whatever you want to put there. So basically, we just showed that this is equivalent to an easier statement to prove, i.e. that if x is odd, then x squared is odd, and then we prove the statement if x is odd, then x squared is odd. And